You're welcome to day 28 of 50 days of tutelage. In this class, I'm going to be teaching you about quadratic equation. So let's get right into it. The general expression is ax squared plus bx plus c equals 0. And then there's another fact that you need to know that in this place, the a cannot be equal to 0. That implies that b can be equal to 0 and c can be equal to 0. And this equation will still remain a quadratic equation. But the moment a equals to 0, then it's no longer a quadratic equation, which is why the quadratic term is actually this first part, which is ax squared. And what you notice is that what makes this a quadratic equation is that there is a term of the unknown that has the power of 2. So quadratic equation will be such that you have an equation and there is a term there that the unknown has the power of 2, and that's the highest power that you can have in such equation. Then with that you have a quadratic equation, and so you can always compare it with this general expression. But one thing I also need to call out is that there is no special attachment with these a, b, and c. They are just constant. Anything can represent them. You can use p, q, and r. In fact, you can switch their place. What you need to understand here is that a in this place is the coefficient of the x squared term, or whatever the unknown, whatever you're using to represent your unknown. The coefficient of that unknown part that is squared is your a, and the coefficient of the unknown part that does not have a power beyond 1, that has the power of 1, is your b, and the constant one without any coefficient, without any unknown, is your c. So therefore, let's do a little bit of exercise here. Of course, if I say negative 3x squared plus 6x minus 3 equals 0, and I give another equation and I say, let's say 3, let me make this 4x squared minus 6, am I repeating the same number? Minus 5x plus 7 equals 0. Then I have another expression. I say this one is 2x minus 14x squared equals 0. And finally, let me just give one more. I have negative 13x plus 6x squared. Then let me have, let's say 5 here. So let's say I have 5 minus 13x plus 6x squared equals 0. So let's just leave it as this anyways. Or I could also have something like this: 2x squared minus 6 equals 0. So if I want you to identify a, b, and c in all this place now, of course, the first two, they are very, very easy because they follow the same pattern. You just say in this first one, a is negative 3, b is 6, and c is negative 3 as well. In the second one, a is 4, b is negative 5, c is 7. You can see that I'm not leaving out the signs. It is very, very important. In this other one now, so what you notice is that what is appearing first here is not the term with x squared. But it does not make that a will now be 2. A is not going to be 2. A is still going to be negative 14. So a is going to be negative 14. Now b is going to be 2 because it is the coefficient of x. But in this case, there is no such thing as constant term. So therefore, your c will be 0 since there is no such thing as constant term. In this place as well, your a is going to be 6 because that is the term with x squared. It doesn't matter that it is the one appearing last there. And then b is going to be negative 13 and c is going to be 5, positive 1. And lastly, you have in this place, you have a is going to be 2. What is b? There is no such term that is the coefficient of x here. So b is going to be 0 and c is going to be negative 6. So now that we have been able to establish that, you should be able to correctly identify your a, your b, and your c in a given quadratic equation. Now, the next thing we want to talk about is that what type of solutions are we expecting for a quadratic equation? So you see, in mathematics, whenever you have equations of this sort, ax squared plus b plus c equals 0. So look at the highest power that you have here. The highest power you have here is the power of 2. Then that also gives you a clue about the number of possible solutions that you have. The number of possible solutions. So for a quadratic equation, you should be expecting two solutions for a quadratic equation. And so those two solutions, they have their property. There are things that you can find out about them even before solving for them. So that leads us to what we call nature of solution. Or in other words, this solution, we also call it the root of the quadratic equation. So nature of roots. Now, these roots, they have some properties that you need to take note. The number one is that they can be real and at the same time, they are unequal. So the two solutions, they are real, but they are unequal. By the way, if you don't understand what I mean by being real, I've already done justice to this in the first day of the class number system, real numbers. So what I mean is that they are real numbers and they are unequal. At least they are different numbers. But they can also be real. That is the two solutions. They can be real and at the same time they are what? Equal. And the last one is that the two solutions can be imaginary. So that is where you begin to have complex numbers. Complex numbers like something of the form I. I've already explained about system of numbers. It is something that you should check out from the previous class. So anyways, this real and equal and imaginary. How do you know that a quadratic equation will give such solutions or such roots? Then we use this thing called the discriminant. So in order to determine this nature of root, we need to use the discriminant. And so what is the discriminant? Throughout this class, I'm going to be representing that with the letter D. The discriminant is given as b squared minus 4ac. So you can see why it is very, very important that you are able to identify what your discriminant is. So b squared minus 4ac. So let's pick any of the two quadratic equations that we have earlier. So I'm going to pick the third one, 2x minus 14x squared, 2x minus 14x squared. Then I'm going to pick, which one again? I'm going to pick this other one as well. 5 minus 13x plus 6x squared plus 6x squared equals 0. So for the first case, let me find the discriminant. So I know that for the first one, a equals negative 14 and b is 2. So therefore, the discriminant of this is going to be, so let me call it d1, is going to be 2 squared minus 4 multiplied by what is a? A is negative 14. But we know that in this place, c is equal to 0. So multiply by 0. So therefore, the discriminant is going to be what? Is going to be 4. And so in this case, because the discriminant is 4 actually, that implies that this is a real number, by the way, and this is going to give us a real root, because in this case we have a positive result. When the discriminant is positive, then you have a real number. However, for it to be equal, for them to be real and equal, the discriminant has to be equal to 0. But when they are real and unequal, the discriminant will be greater than 0. When they are imaginary, the discriminant will be less than 0, meaning that this one positive and this one is negative. So that is what we mean by that. So for real and equal roots, so this one now will give us real roots, but the root will not be equal because the discriminant is not equal to 0, but it is real as well, and it is greater than 0. It is positive. So therefore, we have real roots. So the second one, let's see what will be the nature of the root as well. In the second one, we have a is 6, b is negative 13, and c is 5. So here we have the discriminant will be b squared, that's negative 13 squared, minus 4 multiplied by 6 multiplied by 5. So negative 13 squared, that is 169. Then 4 times 5 is 20. So 20 times 6, that is 120. So here you have 169 minus 120. So that should be 49. So let me quickly confirm that with my calculator. 4 times 6 times 5, that's 120. So 169 minus 120, that's 49. So this is also going to give us a real and unequal root. In fact, I like this randomly selected quadratic equation because they're going to really be useful in the further things I want to explain very soon. So let's go. Now, we have the way we solve quadratic equation. And then the first method that I'm going to be introducing you to is the method of factorization. So, method of factorization. So, how do we factorize? To factorize a quadratic equation, the first thing you need to note is that you need to also check the discriminant. The nature of the discriminant will determine whether a quadratic equation can be factorized or not. And I've been very lucky with the ones I've selected so far. Whenever the discriminant is a perfect square, like it is 49, it is 4. For 49, they are perfect square because the square root of 49 is 7, square root of 4 is 2. That implies that such quadratic equation, you can solve them by factorization method. Once you have a perfect square as your discriminant, then such quadratic equation can be solved using factorization method. So you can see the usefulness of knowing how to handle your discriminant properly. So now, let's go to how do we factorize? You remember that we have generally ax squared plus bx plus c equals 0. So if this is the general thing, the first thing we need to do is that we multiply the terms a and c. So ac, and then we isolate the term b in the middle. So we have b here. So we look for two numbers. So let's say that number is n1 and n2. n1 multiplied by n2. Those two numbers must multiply to give us ac. And when we add those two numbers, they must add up to give us b. If your discriminant is already a perfect square, showing that this whole quadratic equation can be solved using factorization method, then you don't have to worry about it. Just know that you are going to be able to find such two numbers. So I want to show you how to do that now. So let's write this quadratic equation again. 5 minus 13x plus 6x squared equals to 0. So we have 5 minus 13x plus 6x squared equals 0. So the first thing I want you to take note in this place is that you should rewrite it. Let the x squared term come first. You can actually do it this way, but it's just, a lot more convenient that way. So you have 6x squared minus 13x plus 5 equals 0. So in this situation, how do we go about it? So a is 6, c is 5. So therefore, you have your AC is going to be 6 times 5, that's 30. And your B is going to be negative 13. So you're looking for two numbers that when you multiply them, it will give you 30. And when you add them up, it will give you negative 13. So the first way to start is actually that. Note that this guy is a positive number. So if it is a positive number, and this other one is a negative number, that implies that the two numbers that you're looking for has to be negative and negative, because the only way you have a negative number, the only way you add two numbers and to give a negative number is, number one, if both of them are negative, or one is negative and one is positive. That is the only way you add two numbers and you have a negative number. However, in this case, because AC, the product of those two numbers is 30, which is positive 30, then that means that, because if you find a product of negative and positive, that will be negative. So therefore, it's only negative times negative that will give you what? Positive. So therefore, you're looking for two numbers that are negative that you multiply that will give you 30. You can try as many combinations as possible. Like for instance, you can try negative 2 times negative 15. You can also try negative 5 times negative 6. You can also try something like what else is there again? What else can go in 30? You have negative 4 will not be able to do anything here, so 4 cannot go. So we have negative 2 and we have negative 15. Which one again do we have there? So we can have negative 3 times negative 10. So you can see that I also have to think about them as well. So I think we have every one of them already. So when you look at all this combination, try to add them together and see which one of them will give you negative 13. So negative 12, negative 2 plus negative 12, that is going to give you negative 17. Negative 5 plus negative 6, that's going to give you negative 11. And negative 3 plus negative 10, that's going to give you what? Negative 13. So these last two guys, they are our guys. By the way, when you practice this enough, you are going to get, you're going to understand what this is all about. And you're going to be able to do it a lot more smarter. Now, so let's solve it using factorization method now. So what will you use these two numbers to do? So you come down here and you rewrite this. So you have 6x squared But instead of writing negative 13x, what you're going to do is that you're going to write negative 3x minus 10x. So you are going to replace it with these two numbers because this is actually going to sum up to give negative 13. And you repeat the 5, which is the c, which is the last thing there. So you have this now. Now, you have this and 6x squared minus 3x minus 10x plus 5 equals to 0. So therefore, this is going to be, you're not going to group them into twos. So you group these first two together and you group these first two together. So you try to factorize something from there. In this place, you can see that 3x can be factorized. So when 3x is out, what do we have left inside? We have 2x minus 1. In this place as well, negative 5 can be factorized out. So you have negative 5. What will be left inside is 2x minus 1. And that will be equal to 0. So therefore, you have 2x minus 1, 2x minus 1. They are both in common. And so with that, you have 3x minus 5. That is, I'm picking these two now. And I'm only going to pick one of these because they are the same. So you have 2x minus 1 equals 0. So you can see that we've been able to factorize it. And in mathematics, when the product of two things equals 0, that implies that either one of them must be equal to 0. It can be both, but at least one of them will have to be equal to 0. So therefore, if you solve for x in this place, you have 5 divided by 3. And in this place, you have x equals 1 over 2. And that is it for factorization method. The next method is completing the square method. I already explained this in a separate video, so you can see the link right now in a separate video. That is the completing the square method, which also leads us to the formula method as well. You see everything in that video. Last one is the graphical method, which I won't be able to discuss in today's class. So, and that's majorly what quadratic equation is about. You can practice more questions and let me know if you have any challenges. I'm going to respond to you. Make sure you subscribe and like the video as well. I'll see you in the next one.